Hello everyone. In the last class, we finished chapter 1. Today, we are starting the second chapter, which is about acids, bases, and salts. The first thing we'd like to discuss today is what are acids and bases. Well, many people have given us definitions of what acids and bases are, but one of the oldest and the only definition we'll be using in our syllabus is that given by Arrhenius. Alright? So according to Arrhenius, acids are chemicals that provide protons or H plus ions in solution, and bases are chemicals which give you OH minus ions in solution. Now H plus ions can be called hydrogen ions, but in reality H plus ions cannot exist by themselves. They are always attached to another water molecule like this. Now this H3O plus that you see is called a hydronium ion. You can also call it H plus AQ. So whenever I say H plus ion or hydrogen ion, I mean the hydronium ion because we know that H plus cannot exist on its own. So what do we do about this? What about bases? Bases, OH minus ions are stable and they can remain that way in solution. So any substance which when dissolved in water increases the H plus ion concentration is called an acid, and any substance that increases the concentration of OH minus ions are called bases. Alright? So please note that in order for an acid to behave as an acid or a base to behave as a base, you require a medium, water. It has to be in water. Alright? So now that we know what an acid is or what a base is, can we say how strong are acids or bases? Well, first and foremost, the strength of an acid or a base is determined by how much it dissociates in solution. The process by which a neutral molecule gets ionized when you dissolve it in water is called dissociation. Alright? So say you have an acid like hydrochloric acid. By itself, it's neutral. But when you dissolve it in water, it breaks into H plus Cl minus. This is aqueous. This is also aqueous. So in water, you see H plus. You don't see H plus when there is no water. Alright? So the higher the concentration of H plus ions, the higher the concentration of H plus ions, the higher is the strength of the acid. And this is the same for the base, right? Now, not all acids and not all bases dissociate completely, right? So hydrochloric acid, it's a strong acid, it dissociates completely. But you have weak acids like, let's say H2CO3. This is carbonic acid. This does not dissociate completely, right? So the amount of H plus ions in solution are lesser than say HCl or H2SO4 or something like that. And it's the same with the base. There are strong bases like sodium hydroxide or potassium hydroxide which dissociate completely to give you Na plus or K plus plus OH minus. Now these dissociate completely, these are strongly soluble, so these are strong bases. You might have other bases like magnesium hydroxide, which don't dissociate completely, which don't dissolve completely. And those are called weak bases. Another thing to note, strong bases are also called alkalis. Alright? So an alkali is a strong base. So if I say this is alkaline, it means it is basic. You can say acidic or alkaline instead of saying acidic and basic. Okay. So now you know that you can say how strong an acid is or how weak an acid is just by saying how many hydrogen ions or how many hydroxide ions are in solution. But this is very random. Is there a way we can actually see this? Is there a way we can understand this? Or is there a way we can quantify this? Can we say this mathematically? So there was a scale developed several hundreds of or many years ago, I don't know how long ago, called the pH scale. Alright, now it was a Danish person who did this. So P, we don't know what it really stands for. Some people say potens as per German, but pH scale discusses the power of hydrogen in solution. Alright, now it is very simple. You can draw it like a number line. So it stretches from 0 to 14 with the midpoint being at 7. Now where you are on this scale will tell you how acidic or how basic you are. Now the further you go away from 7 towards 0, this is a stronger acidity. And the further you go away from 7 towards 14, it is stronger alkalinity or basicity. Alright, so weaker acids like let's say carbonic acid or formic acid, they come on this side. But very strong acids like sulfuric acid, HCl, they come farther away from 7. And the strongest bases, NaOH or KOH, come towards 14. Weaker bases come here. So how do you measure this? Well, you have devices called pH meters, which are electrodes. You just have to put them in your solution. It will give you a digital readout. But that's not the only way you can do it. Alright? So in order to measure pH, you have what are called indicators. Now indicators give you a color response when it comes to a change in pH. Alright? So what are the common indicators that we use? The first one is litmus. Litmus comes from a lichen. It's a plant product. The second one is phenolphthalein. This comes from an organic compound phenol. You have to perform a reaction called the phthalene fusion to get it. The third common indicator that we use is methyl orange. And the fourth one that we can use is called the universal indicator. Alright, so what about litmus? Litmus comes in two colors, red and blue. So when you are in acid, litmus is red in color. When you are in a base, litmus is blue in color. You get these in the form of paper, alright, litmus paper. When you take a red litmus paper and put it in, let me just write it out for you. So red litmus paper in base turns blue, and blue litmus paper in acid turns red. Now, if you are at pH 7, this pH 7 is a very special point. All right, this is neutral. You have salts like sodium chloride, pure water. So these kind of chemicals are not acidic, neither are they basic. So these are neutral. So a neutral solution, red litmus remains red, blue litmus remains blue. All right. Now we spoke about litmus. What about phenolphthalein? This is usually a liquid. When you drop this in acid, it is colorless. But in base, it is pink in color. So in acid or neutral, you will not see any color change. But the second it becomes a base, phenolphthalein will give you a pink colored solution. What else do we have? We have methyl orange. Methyl orange is in acid, it is orange or red, sometimes even red. But in neutral or base, it is yellow. Okay? So methyl orange is orange or red in acid, but in base or neutral, it is yellow. What about universal indicator? Universal indicator is a combination of several indicator solutions that will give you a variety of colors depending on the pH. All right. So you can get pH paper and you get a chart with it. So depending on what the color is, you can compare that to the chart and you can say, okay, look, this is the pH of my solution. All right. Now, a more detailed explanation of this is given in link 1 below. They speak about pH and they speak about various indicator solutions that you can use. All right. Now that we know what pH is, we know how acids can be classified as strong or weak. We know how bases can be classified as strong or weak. We know the scale of pH. We know the ranges. What is it useful for? What do we actually do with pH? Why do we even need pH? So pH is very important in everyday life. All right. There are things that we might not have noticed at all that won't work without proper pH balance. First and foremost, life processes. Now, there are many processes that happen in the human body, in all plants and animals, that are very dependent on pH. All right. So, if this pH is not maintained, things go bad. Animals die, plants die. So, life processes are sustained in very narrow ranges of pH and they have to be maintained. The second one, for plant and animal life. So many times when we burn coal, we release sulfur oxides, nitrogen oxides, which are acidic in nature. So when it rains, they dissolve in the rainwater and come down as acid rain. Now this acid rain can cause the pH of the water to decrease. All right. So if this happens, you can see river ecosystems or lake ecosystems get affected. If the soil becomes acidic, plants don't grow well. So a lot of plants and animals die because of acid rain. Also, what about the soil? That's another problem. So soil acidification can also be caused, which can also cause other problems to the environment or the ecology. Then pH in digestion. So you might have known for a very long time all your teachers say there is acid produced in your stomach. Yes, the acid produced in our stomach helps in activating certain enzymes that go ahead with digestion. It also helps in killing bacteria or other microorganisms that come in with our food that could cause other harm. So hydrochloric acid is produced in the stomach and the pH is very low. It is around 1.5. So it is all the way over here, somewhere over there. So pH is pretty low in the stomach. It helps in digestion. Also, if you use many acidic food, you will realize that your teeth start wearing out. So tooth decay is caused because of low pH in the food that we consume. So if you drink a lot of carbonated drinks or lemon juice or things like that, teeth can get damaged. Alright? And another important aspect is self-defense. I know that most of you would have been bitten by ants at least once. It burns, right? The reason it burns is because ant bites have an acid that is called formic acid. Alright? Now this formic acid is not a very strong acid, but it's not very weak either. And it can definitely cause damage. You have nettle plants. They also have formic acid, also known as methanoic acid. So these can cause burning, and that is why they are used as self-defense mechanisms. Alright? So now we know why pH is important. Can we list out where we get acids in everyday life? Acids in everyday life, they are very common, right? You have many things like vinegar. This is acetic acid. You might have tasted Chinese food. Vinegar is a very common ingredient over there. Oranges, lemons, limes. These have citric acid in them. Alright? Tamarind, it has tartaric acid. These are all organic acids, but yes, they are still acids. Tomatoes, you know the tang that you get when you taste tomatoes, right? Oxalic acid. And then you have milk, curd, sour milk, sour cream, that is lactic acid. Lactic acid is also produced in the human body. Alright? So ant stings, like we said, nettles, these have formic acid or methanoic acid. Alright? Acetic acid is also called ethanoic acid. So acids are there in our everyday life. In fact, our stomach, we have hydrochloric acid. So acids are not new to us. They are all over the place. And even bases, they are all over the place. Bases are not as common, but drain cleaners, many of your detergents, they all have bases in them to some extent. Alright? So we'll stop here. In the next class, we will understand a little more about acids, bases, and their chemical properties. Thank you.